copper media being used in networking are twisted pair cables, which are Ethernet copper cables used in networking to minimize electromagnetic interference and can reduce interference from external sources. These cables, which fall into two categories, shielded or unshielded. Unshielded twisted pair or UTP cables consist of 4 pairs of insulated copper wires and an outer PVC jacket. Each pair of cables is twisted and separated by a cross divider. This is the cheapest and most common type of cable implemented. Shielded twisted pair or STP cables have 8 copper strands and are coated by a color-coded plastic insulating material. The shielding is done using either aluminum foil, which is denoted by F, and a braided shield, which is denoted by S. Click Next to continue. There are 6 common twisted pair configurations. The letters preceding the slash refers to the shielding on the cable, while letters following the slash refer to the shielding on the individual pairs. Click each to learn more. The 4 pairs of copper cables have an overall foil shield, but the individual pairs are unshielded. Select the next option. The 4 pairs of copper cable have an overall braid shield, but the individual pairs are unshielded. Select the next option. The 4 pairs of copper cables have an overall braid shield as well as an overall foil shield, but the individual pairs are unshielded. Select the next. The 4 pairs of copper cable have an overall braid shield and the individual pairs have an aluminum shield around them. Select the next option. The 4 pairs of copper cable have an overall foil shield and the individual pairs have an overall foil shield around them. Select the next option. The 4 pairs of copper cable do not have an overall shield around them, unshielded, but individual pairs have an aluminum shield around them. Now let's take a look at how each cable type moves data through a network. Click Next to continue. Data transfer rate refers to the amount of digital data that is moved from one place to another in a specific amount of time. It is commonly measured in bits per second or bytes per second. Note, references to bytes are typically used in referring to file size, measured in volume versus speed. In the context of network cables, like twisted pair cables, the data transfer rate can indicate the maximum speed at which data can be transmitted through the cable. This rate is influenced by the cable's construction, category, and length, as well as the quality of the connected hardware and the presence of any interference. Twisted pair cables are grouped into categories that are designed to support different data transfer rates. The higher the categories, the more twists on the copper wire pairs and the more shielding to support higher data transfer rates. This makes the higher category cable more expensive than those of lower categories. For best performance, twisted pair cables should not exceed 100 meters in length. Click Next to continue. To plug a twisted pair cable into a computer and network device port, an RJ45 connector is needed. An RJ45 connector, also known as an Ethernet connector, is a common type of networking connector that is used primarily for wired networks. It looks similar to a telephone jack but is slightly wider. The connector has 8 pins that correspond to the 8 wires in a standard Cat5, Cat5e, Cat6, or Cat7 Ethernet cable. In most instances, twisted pair cables are already factory terminated. However, if you are working with cables that are not, you can use a crimping tool to attach the connector to your cables. The color-coded insulation covers on copper cables plays an important role in determining the order of the cables as they are inserted into the connector. This order of the cable arrangement is known as a pinout. The pinout is governed by 2 RJ45 wiring standards, T568A and T568B. Both standards define the T568A and T568B pinouts for using unshielded twisted pair cable and RJ45 connectors for Ethernet connectivity. The wiring standards T568A and T568B are also used to create a crossover cable, T568A on one end and T568B on the other end, or a straight-through cable, T568B or T568A on both ends. A straight-through cable is terminated with the same pinouts at both ends of the cable, with both sides either having a T568A or T568B, as long as they are the same. This is mostly used to connect a computer and a switch, or a switch to a router. A crossover cable has a T568A pinout on one end and a T568B pinout at the other end. This is mostly used to connect a computer to a computer or a switch to another switch. Click Next to continue. Once you have selected the type of cable you want to terminate, you can use your tools to make your own copper network cable, also known as a patch cord. But first, let's take a look at the requirements and steps for terminating or crimping a RJ45 connector to a twisted pair cable. You'll need the following before starting: the RJ45 crimping tool, the cable stripper, a twisted pair cable, and a local area network tester machine. Click each step. Approximately 1 inch from one end of the cable. Place the cable onto the semicircular section of the cable stripper 1 inch from the end. The blade of the cable stripper should be touching on the PVC jacket of the cable just slightly. Select the next option. Turn the cable stripper once around the cable to create a thin cut around the 1 inch mark of the PVC jacket of the twisted pair cable. Be careful not to cut the color-coded insulation cover of the individual copper wires. Select the next option. Pull the cut PVC jacket outwards from the point at which the cut is made. You should now be left with the twisted pairs protruding just above where the cut was made. Then untwist the 8 wires, straighten them, and arrange them as per T568A or T568B standard. Hold the wires straight with one hand's thumb and index finger. Approximately half an inch of the wires from where the jacket was cut, and cut on a straight line across, using the cutting blade and blade surface of the crimping tool. Select the next option. While still holding the wires, hold the RJ45 connector with the other hand, with the metallic pins facing you, and insert the wires inside the connector. Make sure the wires are still in order. Push the wires to the end of the cable until there is a feel of a tight fit. Select the next option. Insert the connector into the crimping section of the tool and squeeze the handles tight. This pushes down the pins onto the wires to cut through the insulation covers to establish contact with the copper wires. You may squeeze the handles of the crimping tool once more just to make sure the pins are tightly pressed down to the wires. Select the next option. Hold the connector and pull the cable gently just to confirm the wires are held tightly onto the connector. Repeat the steps for the other end of the cable. Note: if the test fails, you may need to repeat it. Crimping a cable several times improves the skill of terminating the cable. Now, let's turn our focus to the world of fiber optic cables. Click Next to continue.